distance, okay? So the centroid is where the medians meet, and if you look at this picture, that means these are congruent, so E is a midpoint, these are congruent, we'll call this F is a midpoint, G is a midpoint. That point where you connect from vertex to opposite midpoint gets you what's called the centroid. And the centroid is for sure the coolest one because it gives you like the center of gravity of a triangle. So if we have time, I'm going to do that for you on here. You construct a median, and then what you'll be able to do is when you find it, you can balance perfectly. I wonder if I can find it without constructing it. I probably have to use this side. I don't know that I'm going to be able to find it. But if I construct it and hold a pencil to it, it balances. Isn't that beautiful? It's the center of gravity of a triangle. I'll try to construct it in a minute. But this is why this works. Your centroid is always 2/3 the distance across your triangle. So this would be like 2/3 of the length of BE, and this is 1/3 of the length of BE. And then this is 1/3 of the length of FC, and this is 2/3 of the length of FC. Okay, so it's always 2/3 and 1/3. It's broken up proportionally. So here's what you have to do with this. It says D is our centroid, and DE has a length of 6. Okay, so this length right here is 6 units. If that is 1/3 of the segment, then what is the length of BD? 12, right? 2/3 would be doubling it. So this is going to be 12. So BD would be 12. DE we said was 6. So what is BE? 18. You take the 6 and the 12 and you add them together. Okay, so notice on that one, I gave you the shorter one. You doubled it, and then you added them together. What if I give you the longer one? What if I tell you that AD is 14? Then you cut it in half, right? The longer one is double the shorter one. So DG would be 7. So AG would be what? 21. 14 plus 7. So 21. Okay, so if I give you the shorter one, you double it. If I give you the longer one, you cut it in half. But what if I tell you the whole thing? What if I tell you that FC is, give me a second, what do I want to use here? 15, we'll say. Okay, if the whole thing, FC, is 15 units, what do? Divide by 3, okay? So that can be a little tricky because if you have the whole thing, you divide by 3, but if you have the longer piece, you divide by 2, and if you have the shorter piece, you double it, right? That's the relationship between them all. So FC, you're going to divide by 3. That means that DF is how long? DF would be 5 because that's the shorter one. DC would be how long? 10. You double it. Okay. So that's really the only thing we do with the centroid is find the lengths depending on what piece of it you've been given. If you're given the whole thing, divide by 3. If you're giving the shorter one, then double it to get the longer one. If you're given the longer one, cut it in half to get the shorter one. Okay, that's the relationship. Questions on that? Okay, orthocenter. This is the point of concurrency for the altitudes of a triangle. So you'll have 3 altitudes drawn in, and the point where they meet is called the orthocenter. That's the construction that we just did. We're not really going to talk anymore about orthocenters because they don't have a cool thing like this, the centroids do. But what you do need to be able to do is take a look at a picture and be able to tell me which one's a perpendicular bisector, which one's an angle bisector, which one's a median. I changed colors, we'll call that blue, and which one is an altitude. Okay, so I'm going to color code. They're color coded on there originally, but I'm going to switch colors so I can mark them for you. So looking at all these lines, there's 4 lines. Do you see the 4 lines?
Yeah.
There's one of each. Can anyone tell me what, well, if I'm going to color code, you know what? I'm going to undo my colors. If you want to use those same colors, you can, but it's not quite going to work for what I'm doing right now. Can anyone tell me what this red one is?
Perpendicular bisector.
Altitude. Angle bisector.
Altitude.
Oh, it is now. No, it's
Altitude or perpendicular bisector?
Perpendicular bisector.
altitude.
Does this look like the middle of this segment?
No.
So it can't be a perpendicular bisector, right?
Oh.
So that is an altitude. It goes perpendicular and it goes through the vertex. A perpendicular bisector doesn't have to go through the vertex, okay? So the altitude is my red one there, okay? Can anyone tell me what this one is?
Angle bisector.
That is the angle bisector, okay? Again, doesn't have to be the middle. It has to be the middle of the angle. So because of these markings, that is our angle bisector. Okay. What is this guy? That is the perpendicular bisector. These segments are congruent. It is perpendicular, so that's perpendicular bisector. And then the last one
Median.
is the median. It goes from the vertex to the midpoint. That's your median. Okay? That is all.